Hello, our project is a brain-computer interface implementation using brain products for neurofeedback studies. With the team members me, Alec, Espina, Santiago, and my companion Yousef Salaman, Maclara. Also with our advisors, Professor Manian. Before going in depth with our methodology, it is necessary to cover some concepts first, which are motor imagery, BCI, and EEG. Motor imagery is the mental execution of a movement without any overt movement or without any peripheral activation. It has been shown that motor imagery leads to the activation of the same brain area as actual movement, namely the primary motor cortex. Many investigations that are related to motor imagery use this information to only prepare the electrodes that are located within that region, which are the electrodes C3 and C4.
A brain-computer interface, or BCI, is a communication pathway between the computer and device based on neural activity generated by the brain. It is a collaboration between a brain and a device that enables signals from the brain to some external activity, such as control of a cursor or a prosthetic limb. A basic BCI system consists of a device that can acquire brain signals like an electroencephalogram, a software that can process the signal into a desired form, and a medium that is being controlled by the user's signals and presents some sort of feedback to the user.
The electroencephalogram, EEG for short, is the most widespread recording modality, which enables more diverse research in the neuroscience field. This is a recording system that basically consists of electrodes, amplifier, AD converter, and a recording device. The electrode, made of silver chloride, acquires the electrical signal from the scalp. The use of conductive gel is important to reduce the impedance between the skin and the electrodes. The amplifier processes the analog signal from the electrodes by amplifying the amplitude of the EEG signal so that the AD converter can digitize the signal in a more accurate way. Finally, the recording device is a computer that stores and displays the data for further processing. EEG is a measurement of the potential difference over time between the active electrodes and the reference electrodes. A third electrode, known as the ground electrode, is used to measure the differential voltage between the active electrodes and the reference points. The electrical activity is recorded in order of microvolts. EEG signals are stochastic and non-stationary signals, which mean its spectrums change with time, showing oscillation at a variety of frequencies.
The subject is going to put on the electroencephalogram's cap. After connecting the electrodes in their corresponding regions and applying the conductive gel to reduce impedance, the process of gathering data will start. The acquisition and filtering of the data and channel selection will be done using a program called OpenVibe. For the signal processing, we will be using a basic fifth-order Chebyshev bandpass filtering with low-cut frequencies of 1 Hz and high-cut frequencies of 60 Hz to select the frequency bands around 1 to 60 Hz, often used for motor imagery. Experiments that involve motor imagery often use the C3 and C4 electrodes and the reference and ground electrodes, which are the ones that are going to be used for this project. The subject will be asked to think of left and right movements, so we can distinguish these particular signals from other noise that might be generated. The acquired data will be used to implement a real-time BCI with the help of MATLAB, so the user can either trace a smooth curve through a given path or select the intended word by thinking left or right. The objectives of this project will be for the student to 1. Familiarize with BrainApp products, MATLAB, and OpenVibe. 2. Assemble the BrainApp equipment and link it with MATLAB and OpenVibe. 3. Design and implement a simple BCI.